Hello everyone, welcome back to the day 7 of TryHackMe's Advent of Cyber 2024. Continuing with our series of the Advent of Cyber, we have reached the day 7. It says AWS log analysis. Oh no, I'm speaking in CloudTrail. The story. As Stockman's approach, so did the need to provide those without with something to read. Careful was tried, they made it their mission, a gift for all wares, a sock mask tradition. Although they had some, they still needed more. To pick up some books, they head to the store. The town's favorite books would no doubt make them jolly. They ticked off the list as they filled up the trolley. With the last book ticked off, the shopping was done. When asked for their card, the ware handed them one. I'm sorry, he said, as the shop clerk reclined. I can't sell you these books as the card has declined. The ware put them back as they walked back in confusion. How could this be? An attack? An intrusion? And when they logged on, the ware got a scar. To find the donations, they just weren't there. Monitoring in an AWS environment. Care4ware's infrastructure runs in cloud, so they chose AWS as their cloud service provider. Instead of their workloads running on a physical machine on premises, they run on virtualized instance in cloud. These instances are in AWS called EC2 instance, Amazon Elastic Compound Cloud. A few members of the wearable SOC aren't used to log analysis on the cloud, and with the change of environment comes a change of tools, and services need to perform their duties. Their duties this time are to help Care4West figure out what has happened to the charity's fund. To do so, they will need to learn about AWS service called CloudWatch. What is CloudWatch? AWS CloudWatch is a monitoring and observability platform that gives us greater insight into our AWS environment by monitoring applications at multiple levels. CloudWatch provides functionalities such as monitoring of system and application metrics and configuration of alarms on those metrics for the purpose of today's investigation. So we want to focus specifically on CloudWatch logs. Running an application in a cloud environment can mean leveraging lots of different services. Example, a service running functions triggered by that application, a service running the application backend, etc. This translates to logs behind generated from lots of different sources. CloudWatch logs makes it easier for the users to access, monitor, and store the logs from all these various sources. A CloudWatch agent must be installed on the appropriate instance for application and system metrics to be captured. Key feature of CloudWatch logs that will help the wearable SOC squad and us make a sense of what happened in their environment is the ability to query application logs using filter patterns. Here are some CloudWatch terms you need to know before going further. Log events. A log event is a single log entry recording an application. Event. Those will be timestamped and packaged with log messages and metadata. Log streams. Log streams are a collection of log events from a single source. Log groups. Log groups are collection of log streams. Log streams are collected into log groups when logically it makes sense. For example, if the same service is running across multiple hosts. CloudTrail. CloudWatch can track infrastructure and application performance. But what if you wanted to monitor actions in your AWS environment? This would be tracked using another service called AWS CloudTrail. Actions can be those taken by a user, a role granted to the user giving them certain permission, or AWS service and are recorded as events in AWS CloudTrail. Essentially, an action the user takes through Management Console or AWS command line interface or service will be captured and stored. Some features of cloud trials include always on, JSON formatted, event history, trials, and deliverables. You can read through the description here. I will go forward. As mentioned, CloudTrail helps capture and record actions. These actions could be interactions with any number of AWS services. For example, service like S3, Amazon Simple Storage Service, used for object storage, and IAM, AWS's Identity and Access Management Service, can be used for secure access to AWS environment with the creation of identities and assigning of access permission to those identities. Will have actions taken within these service recorded. These recorded events can be very helpful when performing an investigation. Intro to JQ. What is JQ? Earlier, it was mentioned that the CloudTrail logs were JSON formatted. When investigated in large volumes, this machine readable format can be tricky to extract meaning from, especially in the context of a log analysis. The need to arise for something to help us perform and filter the JSON data into the meaningful data we can understand and use to gain security insights. That's exactly what JQ does. Similar to command line tools like SED, AWK, and grep, JQ is a lightweight and flexible command line processing that can be used on JSON. It's basically a command line tool which can be used for properly formatting the JQ or the JSON file data and then put that on our screen in a beautiful manner. How can it be used? Now let's take a look at how to use a JQ to transform the filter JSON data. The wars being the wars, they stored their shopping list from the trip to the bookstore in JSON format. Let's take a look at that. Book title, Werewolves Valley, genre, and page count. And we can see a list of books here and their what it is meant for and the number of page counts here. So you can see that it's in the format of the flower brackets inside which we have a list of keys and pairs for it. Key value pairs. It looks like a dictionary if you are working with dictionary in Python. It looks similar to that. JQ takes two inputs, the filter you want to use followed by the input file. We start our JQ filter with a dot which tells the JQ we are accessing the current input. From here, we want to access the array of values stored in our JSON with the big brackets, making our filter a dot big bracket. For example, let's run the following command. This is JQ with the pointer and the object that we want to access along with the JSON file which is there in the system. The command above would result in this output. The book title, page count. It's going to format it in a better view for us to look at. Once we have accessed the array, we can grab elements from the array going one step deeper. For example, we could run this JQ command. Now we are going to be specifying that we only want the book title by specifying with the header or the key value of the file in it. So here we want the book title, so we mentioned dot book title, which is going to give us list of all the books which are present with their title name. The peculiar case of Care4 was dry funds. Now that we have refreshed our knowledge of AWS CloudTrail and JQ alongside Mixkitty, let's investigate this particular case of Care4's dry funds. The responsible where for the Care4's charity drive gave us the following info regarding this incident. We sent out a link on 28th of November to everyone in our network that points to a flyer with the details of our charity. The details included the account number to receive donations. We received many donations the first day after sending out the link, but there were none of them on the second day. I talked to multiple people who claimed to have donated a respectable sum. One showed his transaction and I noticed the amount number was wrong. I checked the link and it was still the same. I opened the link and the digital flyer was the same except for the account number. Mixkitty recalled putting the digital flyer Weber's bank account qr.png in an Amazon AWS S3 bucket named Werewolves Care4 Wells. Let's assist Mixkitty and start by finding out more about that link. Before that, let's first review the information that we currently have to start the investigation. The day after the link was sent out, several donations were received. Since the second day after sending the link, no more donations have been received. A donator has shown a proof of his transaction. It was made day 3 after he received the link. The account number in the transaction was not correct. McSkitty put the digital flyer in the AWS S3 object named wherewillsbankaccount.qr.png under the bucket where will care for where. The link was not being altered. Glitch did it. Let's examine the CloudTrail log related to the where will care for S3 bucket. For quick example, a typical log entry looks like this. Now let's try to replicate this in our attack box. Let's open up the terminal here, and then let me zoom this terminal here. Let's list out all the contents that is present in this directory using the command ls. Here we see a folder called as wherewill's log. Let's browse to that using the command cd wherewill logs. Now looking at the contents of it using the command ls, we see two files to be present, CloudTrail.log.json and rds.log. Let's use the command cat to just concatenate the contents inside the log.trail.log.json. Press enter. You can see that this is how a log would typically look when you directly extract it or get a raw dump from the source. Now coming back to our TryHackMe's page, it might be overwhelming to see the sheer amount of information in one event, but there are some elements that we can focus on for our investigation. We can look for the fields of user identity, which would give us the detail of the user account that acted on an object, event time, when did the action occur, event type, what type of event occurred, event source, from what service was the event logged, event name, what specific actions occurred, from what IP did the action happen, user agent, what user agent was used to perform the action, request parameters, what parameters were involved in the action. By using the guide above, we can read the example of the log entries as follows. The I am user wherewill character listed all the objects of the S3 bucket named AOC CloudTrail wherewill. The IP address from which the target originated is 34247.218.56. The user agent indicates that the request was made using AWS SDK tool for Go. Now that we know where to look, let's JQ to filter the log for the events related to the wherewill's bank account qr.png S3 object. The goal is to use the same elements to filter the log while using the JQ and format the results into the table to make it more readable. According to McSkitty, the logs are stored in the wherewill's log directory. Now let's start investigating the CloudTrail logs by executing the command below. Let's copy the command and then paste in the command into the clipboard. Close this and press Ctrl+Shift+V to paste the command. Now let's break down this particular query that we have. JQ is the tool's name. -R specifies that we want a raw output from the file that we are specifying. Records is going to be the specific header that we are trying to look for in this particular file, which is the dot record. And then a pipe symbol says that from the output of that, filter these contents. Select event.source is equal to the one which is s3amazon.aws.com, which is specifying the event source from where this originated, and request parameters.bucket name, the folder name or the file where it needs to be looking at, the wherewell care for where's, and the file names at last we are supposed to be mentioning, which is CloudTrail.log.json. If you press enter, you can see a list of logs coming out in our screen here. This is a lot of information to actually process, but we have a detailed description of what has happened in this event log. Coming back to the page, as you can see in the command output, we are able to trim down the results since all the entries are from S3. However, it is still a bit overwhelming since all the fields are included in the output. Now let's refine the output by selecting the significant fields, executing the following command below. Now let's copy this particular query. Coming back to our terminal here, scrolling down, let's paste this command here. Now breaking this command up, we can see the JQ command, the raw, and we're selecting the records as our header. Now we specify select.eventSource is equal to s3amazon.com and the request parameters and bucket name where will care for where. Now we are also specifying for further filters of event time, event name, user ID, entity username, and we are going to be formatting it with NA, which is going to bring in the space between the output. So we are specifying that we want the request parameter dot bucket name, then the request parameter dot keys and source IP address to also be printed out. Let's press enter. And now we can see that we have got the following output, which specifies the event time, the event name, the user ID, the bucket name, the parameters which is not available, and the source IP address from where the location was triggered from. Coming back to our TryHackMe's page, as you can see in the result, we could now focus on the noticeable items. But our initial goal is to render the output of the table to make it easier to digest. Let's upgrade our command with the additional parameter. Let's copy this query, paste in this command which we copied from the TryHackMe's page. Let's come here, clear our window, and then paste this command here. Now breaking down this query, we see that we have specified it in a table format, for which we say we want the event time, event name, username, bucket name, key, and the source IP address, which is going to then be filtered or be grabbed from the records header of the s3amazon.com from the bucket name called as where will care for where's to the following filters of event time, event name, user identity, and then the request parameter of the bucket name basically, then request parameter keys, source IP address, and then specifying all of them in a column type with the column -t. This is going to give us the output in the table format. As you can see it here, we have all the information in a table format, which is pretty easy and noticeable for us during the analysis of these logs. Coming back to our TryHackMe's page, a crafted command lets us simulate S3 activities from the CloudTrail log. Now that we have crafted a JQ query that provides a well-refined output, let's look at the result and observe the events. Based on the columns, we can answer the following questions to build our assumption. How many log entries are related to the where will care for bucket? Which user initiated most of these logs entries? Which action did the user perform based on the event name field? Were there any specific field edited? What is the timestamp of the log entries? What is the source related to these log entries? Looking at the result, 5 logged events seemed related to the where will care for buckets and almost all related to the user glitch. Aside from listing the objects inside the bucket list object event, the most notable detail is that the user glitch uploaded the file where will bank account qr.png on 28th November. This seems to coincide with the information we received about no donation being made 2 days after the link was sent out. Mixkitty is sure that there was no user glitch in the system before. There is no one in the city hall with that name either. The only person that Mixkitty knows with the name is the hacker who keeps himself. Mixkitty suggests that we look into the anomalous user. From this output, we can see that on 28th of November, we can see the user glitch modifying the system with uploading a new where will bank account qr.png into the system from the same IP address, doing other operations like listing of the objects, uploading the objects, and looking at contents here. We see the most 5 relevant logs of it. Now, coming back to our TryHackMe's page, Mixkitty fooled us. Mixkitty wants to know what is the anomalous user account has been used for, when it was created, and who created it. Enter the command below to see all the events related to the anomalous user. We can focus our analysis on the following questions. What events are included in these log entries? What is the timestamp of these log entries? which IPs are included in these log entries, what tools or OS was used in these log entries. Let's copy this query, paste it here, and coming back to the terminal here, let's paste that command. Now analyze the query. JQ raw and then the table format, event time, event source, event name, username, and source IP as a format of a table header, and then grepping those information from the records of the one matching for the username called glitch from event time, event source, event name, and user identity dot username. It's going to grep all this information and supply it to the name or the table that we have specified. Then we're also specifying the source IP address and specifying our file that we want and then passing it to the columns for creating a table. Let's press enter and we see a lot of information coming out here. We see that the event names of head bucket, list objects, uploading some objects, and getting cost and usage, listing buckets, and all this information happening by the user glitch from the same IP address here. We see a lot of different timestamps here, but all related to the 28th of November. So coming back to the page, we see the results show that the user glitch mostly targeted the S3 bucket, the notable event in the Cloud Console login entry, which tells us the account was used to access the AWS Management Console using a browser, but still need information about which tool and OS were used in the request. Let's view the user agent value related to these events using the following command. Let's copy this command, paste it in the clipboard of this operating system, and then let's close this, paste it in here in our terminal, and let's press enter. So here we get a list of all the other information, but now we also have added the user agent parameter that we want to look into. So we can look at the user agent or the one which the browser uses for sending in the metadata of the system to the web browser. There are two user agents, values included in all log entries related to the glitch user. One which is going to be talking about the AWS's console control, which is used only for the AWS's internal accessing and managing stuff, which does not give us much information about this. But whereas the another user agent which specifies that it is running which is using a Mozilla based browser on a Macintosh operating system using Intel Mac OS, which proves that it's running a Mac OS and they are accessing the application using a Chrome browser. An experienced attacker can forge these values, but we should not dismiss this information. It could be valuable when comparing different log entries for the same user. We will park the current information for now. Let's gather more information to connect the dots. The next interesting event to look for is who created this anomalous user account. We will filter for all IMA related events, and this can be done using the select filter event source is equal to ima.amazon.com. Let's execute the command below and try to answer the following question. What event names are included in the log entries? What user executed these events? What is the user's IP? Let's copy this query and let's paste it in our terminal here. And let's press enter. This gives us a lot of information. But surprisingly, we see that MixKitty was the one who has authorized to create a login profile, create users, and all those things. But this is matching the same IP address of the one which was trying to modify or upload different accesses to the system. That's surprising. Let's have a more detailed look at the events related to the create user action by executing the command below. Let's copy the query here and paste it in here and press enter. From this output, we can see that MixKitty was the one who created a user called as glitch on 28th of November from this particular browser of Macintosh and using Chrome. So that is a little surprising. Is MixKitty the one who has authorized it actually, or is MixKitty compromised? Let's continue reading. Now that we know the permissions the anomalous user has, it could be devastating if it has access to our whole environment. We need to filter out for the attached user policy event to uncover the permission set for the newly created user. This event applies accesses policies to user, defining the extent of access to the account. Let's filter for the specific event by executing the command below. Let's paste the command down here and press enter. This output says that the user glitch has an administrator access into the system, which could mean that the user glitch could have a complete access to all the logs of the file system. MixKitty is baffled by the result. She knows that she did not create the anomalous user and did not assign the privileged access. She also doesn't recognize the IP address involved in the event and does not use a Mac OS. She only uses a Windows machine. All this information is different to the typical IP address and machine used by MixKitty. So she wants to prove her innocence and asks to continue the investigation. Logs don't lie. MixKitty suggests looking closely at the IP address and operating system related to all these anomalous events. Let's use the following command below to continue with the investigation. Let's copy this and paste it in here. Press enter to look at the output. Now looking at the output, we clearly see that we have a user called Mayor Malware, Glitch, and MixKitty having the same IP address, which is suspicious as different users cannot be on the same network or the same IP address accessing all of them at once. Now, which means that we need to filter to see if Mayor Malware is using the same IP address as MixKitty and Glitch all the time to see the previous records to tie up these IP address to the Mayor Malware. For that, let's paste in this command here and then press enter. Here we see that the source IP address and the user agent which is being used by the Mayor malware matches the one with the glitch and MixKitty. But now let's also check which browser and IP address does MixKitty always tries to access her system from. So let's come here and modify the request from Mayor malware to MixKitty. Press enter. Here down we can see that MixKitty uses Windows file system of Windows 10 running an Chrome browser, and the IP address used by MixKitty is different compared to the one used by the Mayor, which proves us that the Mayor malware was behind the compromisation of MixKitty's account and creation of the glitches account. That's bad, Mayor malware. Coming back to this, definite evidence. MixKitty suggests gathering stronger proof that that person was behind this incident. Luckily, Bevel's Bank cooperated with us and provided their database logs from their Amazon relational database service. They also mentioned that these are captured through their CloudWatch, which differs the CloudTrail logs as they are not stored in JSON format. For now, let's look at the bank transactions stored in the Bevel's log rds.log file. Since the log entries are different from the log previously investigated, MixKitty provided some guidance on how to analyze them. According to her, we can use the following command to show all the bank transactions. So let's come here and use the same command. Before that, let me clear my terminal here and say grep. Look for any of the command which says insert in the RDS log. Press enter. Here we see a log of inserting the value or modifying the value, saying that insert into Bevel's bank transaction the account number, account owner, and the amount to the following values. It's modifying the values from the original one to the number which is of the account number of Mayor malware and the amount which was given or the transaction or the donations given by the people of the town. And this happens on 28th of November, which is the same exact timeline where all the transaction had stopped coming from. As shown above, the Care4West fund received all donations until it changed into a different account at a specific time. The logs also reveal who received the donations afterwards. Given the account owner's name with all these findings, MixKitty confirmed the assumption made during the investigation of the S3 bucket Since the sudden change in the bank details was reflected in the database log, the timeline of events collected by Mixkitty explains the connection of the actions conducted by the culprit, timestamp, source, and the event. Now let's go to the challenge or answer these questions today. What is the other activity made by the user glitch aside from the list object action? Let's open up our terminal back here again and enter this following command and press enter. Now here we see a list of event names which the user glitch did, and we see that other than the list object, we see put object, which is to upload a file or modify the file, has been done. Let's copy that and go back to the page here and paste it in here. Which answers today's question. What is the source IP related to the S3 bucket activities of the user glitch? Let's come back to the terminal here and copy the IP address. Let's copy this and paste it in here. Press enter. Based on the event source field, what AWS service generates the console login events? Let's come back to the page here and then modify the query to say that we need, let's say, event name is equal to console login. Here we see it is sign in Amazon AWS.com. Let's copy that from our clipboard and paste it in here. When did the anomalous user trigger the console login event? Now we can see that from our output here. Malware, Mixkitty, and the glitch, who is our anomalous here. Let's copy this, open up the clipboard, and paste it in here. What was the name of the user that was created by Mixkitty user? This glitch. What type of access was assigned to the anomalous user? We have got it that it was an administrator. For that, let's run this following command and press enter. Here we see the access which was given to the glitch user. Let's copy this and paste it in here. Which IPE does the malware typically use to log into AWS? For that, we can browse for the IP address of the malware's event logs. And here we see the IP address to be 53.94.210.69. Let's copy that and paste it in here, and we say it's the right answer. What is Mixkitty's actual IP address? Let's come here and then change this to Mixkitty and press enter. Now this gives us a lot of information, and down here we can see Mixkitty's official IP address. Let's copy that. Paste that in here and press enter. What is the bank account number owned by the malware? Let's open up the bank statements given us by the bank by using the command grep, insert, and from the file log of RDS log. And here we can see the value of the bank account number. Let's copy that and then submit it. That's the right answer. Want to learn more about log analysis and how to interpret logs from different sources? Check out the log universe room. That is it. So we have officially finished the day 7 of Advent of Cyber. By this, we have officially completed the 1 week mark of Advent of Cyber. So hope you liked it. If you did like it, click on that like button. And if you're new to this channel, hit on that subscribe button. And super thank you to everyone who comes here and tunes in with me solving the Advent of Cyber 2024. So that is it for this video. Hoping to see you all tomorrow for the day 8 of Advent of Cyber. Till then, stay happy, stay smiling. Bye bye.